Hello and welcome to this short IGCSE Marine science video. We're looking at section 6.8 about climate change. Now I'm just going to go over the part that are in the syllabus, and I'm just going to state that there are maybe a few places here where I think Cambridge is very careful in their wording, and just for the record, I'm maybe a little bit more worried about climate change than Cambridge is. As always, all the information here is on my reputation alone, so don't blame Cambridge if anything here is wrong. Let's get on with the video. So here's the syllabus for the chapter. So it talks about change over time. It talks about the present effect of methane and carbon dioxide. It talks about the effect that CO2 has on seawater, and explaining the role of the ocean in absorbing heat. We should also be able to look at thermal expansion and melting of land-based ice. And we should be able to look at the possible impacts of the increasing greenhouse gases on our marine ecosystem. So let's look at the basic for the greenhouse effect. First, solar radiation, it travels from the sun to the earth, and this is mainly in the form of visible light and UV light. Some of that will be reflected by the earth and the atmosphere, especially if we have cloud cover, if we have aerosols in the air. But some of the radiation, it will warm up the surface of land and water and warms it up. By the way, just so you know, if we have ice cover, ice will reflect more light than the water will. And this is called the albedo effect. So when the surface is heated up, this is then released again as infrared energy. And infrared energy passes up through the atmosphere, but some of it is absorbed and re-irradiated by greenhouse gases. So greenhouse gases traps some of the infrared radiation in our atmosphere. And this is, by the way, not a bad thing. Without the greenhouse effect, our planet would be way cooler, and it'd be quite hard to live many places here. Here we see a graph that shows the change in the average temperature from around 1860, when we really saw industrialization starting up, coal-fired power plants, locomotives, and so on, until today. And you can see there's a general trend that the temperature goes up and down. There's always variation. So some years it's higher, some years it's lower. But from 1950s until today, we see a clear trend line where the temperature is increasing, and increasing in a significant amount. Also, if we just look at the last 4 or 5 years, we've seen an increase that is larger than we would have expected. But it's also important to remember that, yes, our temperature has been changing over the last million years. And how do we know that? Well, it's outside the syllabus, but stuff like drilling for ice cores and looking at isotopes can give us an indication of how climate was in the ancient years. And we have seen ice ages before our time, and now we are clearly in a period of warming. So the question is, of course, how much of this is our fault? And science is pretty clear that we humans are contributing to global warming by adding more greenhouse gases to the atmosphere. So this graph here, it shows CO2 concentration. And as we can see, CO2 concentration has not been constant either. CO2 goes up and go down. Volcanic activity releases CO2. We have some geological process and stuff like downwelling will capture CO2. So there will be a general flux between a higher CO2 concentration and a lower CO2 concentration. That's quite natural. But if we look at where we are now, we right now has an average of over 400 parts per million, which is way, way higher than anything we've seen in the last many years. So we are changing Earth's atmosphere in a significant way, and this is going to have an impact. If we look at who are the main emitters of CO2 and greenhouse gases, CO2, United States and India and the European Union and Russia are the leading causes by far, by very, very far. And there are many countries who are contributing very, very little. So in general, it's the big economies here in the world, the big industrial economies, who are responsible for most of the extra CO2 released to the atmosphere. Well, the natural cycle is, of course, that sunlight hits our producers, and our producers, they take CO2 from the atmosphere, and then we have carbon fixed here in the tree. Some of that carbon will then be eaten by consumers. In this case here, it's an animal in the marine. This here will be our algae, and this here will be our primary consumers. And then plants, they respirate, and animals, they respirate. So this brings CO2 back into the atmosphere. Some will decompose, and this will also go back into the atmosphere. This is kind of the natural cycle. Where we're changing the cycle is with the fossil fuels here. When we dig up fossil fuels here and we burn them, we release extra CO2 to the atmosphere outside the normal cycle. And this is more CO2 than our producers can use. Therefore, the amount of CO2 in the atmosphere, and hence in our seawater, is increasing. If you look at this in the ocean, we kind of have what we call a biological pump in the ocean, where phytoplankton, it captures a lot of carbon, and some of that will eventually fall to the bottom of the ocean. This is actually how fossil fuels were formed, by ancient algae and plants who went to the bottom. But we also have CO2 released back to the atmosphere by respiration, both by microorganisms and by both producers and consumers. But in general, the oceans hold way more CO2 in the atmosphere, and that is because water has a good capacity for binding CO2. So CO2 is the greenhouse gas we talked about here, but water vapor and methane are also greenhouse gases. Especially methane is a very powerful greenhouse gas because it's very good at absorbing infrared radiation. So compared to CO2, methane is actually a more powerful greenhouse gas. So large releases of methane will be quite troublesome to the climate. One of our big issues is that, especially in the permafrost, we have a lot of frozen methane bound, and as temperature increases, well, the permafrost, it thaws, and then more methane gets released, increasing the temperature even more, and then we kind of have a feedback cycle where suddenly the global warming can go into a positive feedback cycle. Methane production comes from wetlands, as I said before, thawing permafrost. It comes from animals, cows for example, decaying vegetation, rice farming, and especially from cattle farming. So the fact we have so much cattle now and we need so much rice is also driving our levels of methane. Methane can also escape when we drill for gas and for oil. So when our planet is warming up, most of the heat is taken up by the ocean. Oceans has a very high heat capacity, so it takes up a lot. It will take a lot of energy to heat it up. We all know that when we're at home, if you use a hair dryer, we get warm air right away. But if you want to boil potatoes, well, it takes some time for the water to get boiling. So it requires a lot of energy to heat the water. But then again, once it is hot, it will stay warm for a long time. So the issue is, luckily for us, most of the heat and most of CO2 is absorbed by the ocean. The problem is this also will make our ocean warmer and more acidic. One of the physical properties of water is that water has the highest density about 4 degrees. We all know ice has a higher density because it floats, but as water gets warmer, the density gets lower. That's also why we have the thermoclines in summer, where we have the hot water lying on top of the cold water. So hot water takes up more space. And this is one of the reasons why we expect to see sea levels rise, simply because warm water takes up more space. Another thing that can increase water levels is the melting of ice on land. When ice on water melts, it will not increase the water level, but when ice on land melts, well, then the fresh water will run out into the ocean and it will increase the volume of water in the ocean, which then can lead to a rising water level. It can also do some funny things to salinity and productivity, but what we mainly think about in this chapter here is that as land-based ice, which we see on Greenland and Antarctica, when it melts, it will release a lot of water to our ocean. And there's so much land-based ice, so that if all the ice in Greenland were to melt, ocean levels would rise about 6 meters, which would put many of our current cities in, well, a kind of wet state. And as we expect, well, we do see that water levels are rising. It's not fast, but they are rising. And one thing important is that when water levels rise, it also means that storm surges will get even higher. So while a small increase in the water level might not mean a whole lot, if you then have a storm and a storm surge, well, then the water might be high enough to like breach a dike somewhere and go in and flood huge areas. So even small increases in global sea level can have quite serious consequences for coastal communities. There are many impacts when we have global warming. Increased sea level is one of them, and this can also lead to change in coastal areas. Storms get stronger. Tropical storms, hurricanes, cyclones, typhoons are powered by warm water. So as water gets warmer, tropical storms will get stronger and more destructive. Rainfall patterns can change, and this can lead to issues both with farming um, and with infrastructure. If we've got very strong rainfalls coming in and destroying coastal infrastructure, and the El Nino La Nina cycle can be affected, and this can lead to changes in global fishing patterns. One of the organisms that can be really affected by global climate change is our corals. Corals, they like warm water, but they don't like too warm water. They're a bit like Goldilocks. They want everything just in the right range. In a healthy coral, you'll have a symbiotic relationship between the zooxanthelle and the coral, which is what gives the corals its beautiful colors. If there is stress from environmental issues, well, the algae can leave the coral and then the coral is bleached. It doesn't mean the coral is dead, but it is in trouble. And if the bad factors they continue, if the temperature continues to be high, well, then the coral will eventually die. Um, this can be caused by uh, increased ocean temperature. It can also be caused by pollution. Can also be caused by overexposure to sunlight, extreme low tides, and stuff like excessive use of sun cream by divers can also damage the coral reef and bleach them. Our corals face a double whammy because with more CO2 in the water, we also see a lowering of the pH. This is called ocean acidification because CO2 is a weak acid in water. It forms carbonic acid. Carbonic acid is the one you see when you open a cold Coca-Cola or a Fanta or something, and you see the bubbles coming up. So as we see with seawater pH is get lowered, it gets harder for animals who use calcium carbonate to use this for building their skeletons. And since corals are built of calcium carbonate, a more acidic ocean will make it harder for them to build the structure they depend on. As climate changes, marine species that are adapted for cooler water will shift their range further towards either the north or the south to find water of the temperature they prefer. And species such as polar bears, who depend on floating sea ice for hunting, will have smaller areas to hunt in. Scientists have found already that in the North Atlantic, cod and halibut are becoming rarer in the more southern areas, but are caught more frequently in the northern areas. And for example, here in Denmark, we are starting to see arrival of warm water species such as tuna. Migration patterns may no longer be suitable for the species that rely on the presence of food in specific places. For example, humpback whales traditionally migrate to polar waters when rich populations of krill appear after the ice starts to melt. If the ice melts earlier, the fear is that the whales will arrive in the polar region too late for the sudden increase in kill, and this will lead to less food for the whales. Global warming can also cause habitat loss and disruption of food chains. So global warming is changing our climate and it is changing our ocean. And it is a problem caused by humans, so it's also a problem that needs to be solved by humans. And basically, it requires us to step up to the task and do something about it and not just, as I'm doing here, talk about it.